Assalamualaikum and good morning. My name is Khadija bin Surami, matrix number AN200155. Today we're going to present about when task filter circuit design using OPM. This group 5 included Muhammad Luqman, Imad Yusuf, Salman Shah, and Raditya. In this video presentation, we're going to talk about introduction to bandpass filter, methodology, result, discussion, and conclusion. Introduction to bandpass filter. A bandpass filter is defined as a device that allows frequency within a specific frequency range and it also rejects frequencies outside the range. There are many types of bandpass filters, but in this project we are more focusing on active types. A bandpass filter are widely used in wireless transmitters and receivers. It can be found in sonar, electrocardiograms, lasers, and more. We can say that filters, bandpass filters, are used in every industry in different ways and for a different purpose.
Hi, my name is Imad Yusuf bin Saadun, matrix number AN200075, and I will be presenting about methodology. For this group project, I use PSpice software to design this circuit. This circuit includes 4 resistors, R1, R2, R3, and R4, 2 capacitors, C1 and C2, 1 AC power supply, 2 DC power supply, and 1 OPM. Each DC power supply is connected to each terminal of the OPM. The power is set to be 12 volt for each, and for the circuit 10 volt. This circuit is designed by referencing from online and getting some infos from the seniors. To note, this circuit need to be grounded so the output graph for this bandpass filter circuit could be obtained. I think that's all from me. Thank you.
Salam sejahtera and good morning. My name is Tritia Lai Anading. Today I will present about result and discussion with my partner, which is Muhammad Luqman bin Ismail. So as you can see from this slide, this is the output signal of the active bandpass filter that our group is conduct. And in the previous slide, our teammate, which is Imad Yusuf, will explain in detail about the circuit. So the shape of the frequency response curve will be determined by the filter circuit characteristic, with the curve above defining a ideal bandpass response. An active bandpass filter is a second order filter because it has two reactive components, which is two capacitor. So proceed to next slide. A bandpass filter is a circuit that only allows a specific frequency band to pass. This passband span the cutoff frequency FL and FH. In this case, FL denote the lower limit frequency and FH denote the upper limit frequency. The center frequency, denoted by the letter FC, is also known as the resonant or peak frequency. FL value always be less than FH value. The filter passband is nothing more than its bandwidth. The filter gain is maximized at resonance or center frequency, which is FC, which is referred to as the overall passband gain. Okay. As you can see from this block diagram of active bandpass filter, the circuit diagram for the active bandpass filter is divided into 3 sections. A high-pass filter is the first component. The OM is then used to amplify the signal. The final component of the circuit is the low-pass filter. The signal will first pass through a high-pass filter, the output of which will tend to infinity, and then to a low-pass filter at the end. the high frequency signal will be filtered out by this low pass filter. The simple band pass filter is obtained by cascading the high pass filter and the low pass filter. The low pass and high pass circuit must be connected in the same order to realize this filter. So my next point is this Q factor indicate how selective or unselective the band pass filter is toward a specific frequency range. The lower the Q factor value, the wider the bandwidth of the filter. The higher the Q factor value, the narrower and more selective the filter. As you can see from the previous slide, this is unselective uh, unselective the band pass filter since it has the lower Q factor value. When analyzing an active filter, a normalized circuit is used, which result in a ideal frequency response with a rectangular shape and a transition between the pass band and the stop band with an abrupt or very steep roll of slope. However, because ideal responses are impossible to obtain in a real practice, we must rely on approximation to achieve the best frequency response possible for the type of filter we are attempting to design. So in the next slide, my partner will discuss in detail about the calculation of the result and discussion. That's all from me. Thank you.
Yes, Assalamualaikum warahmatullahi wabarakatuh. Thank you, Tia. So I will continue for the modification parameters of our circuit. So as you can see, we have calculated the frequency of the high pass and low pass filter. So by using the formula, you have calculated the frequency of it is 355.88 hertz and approximately 503 hertz for high pass and low pass filter respectively. So by knowing the FC1 and FC2, we have find the bandwidth and the center frequency. So the bandwidth is approximately 147 hertz, and the center frequency, or we can say it as resonant frequency, is approximately 423 hertz. So by knowing the bandwidth and the center frequency, we have find the Q factor, quality factor, which is approximately 2.88. The Q factor in short is just the center frequency, the ratio of the center frequency to the bandwidth. So by knowing the Q factor, we can conclude that our circuit is categorized under the wide bandpass filter. So that's the parameters of our circuits. That's all for me. Thank you.
So moving on to the conclusion. So throughout this project, we acquired many input regarding bandpass filter, and as well as other knowledge related to electronic communication system. So we have conducted countless of research and came out with a design which are effective, efficient, and most importantly, the bandpass filter works splendidly. Thus, we wouldn't hesitate to say that our bandpass filter design has fulfilled the criteria of a good bandpass filter. So it actually has been proven based on the result theoretically and practically through simulation and calculation, so that we hope that in the future our design of bandpass filter will give benefits to other and might as well to a certain extent contributed to the advancement of technology. So that's all from us. Thank you and see you in the Q&A session.